moving right along, we're going to try number 8 now. So here we go. This is x over 5 plus x equals 3/10. Hopefully this won't take too long. So we always want to combine like terms and put all the x's on one side and all the constants on the other side. So let's see how that works here. All right, x over 5 plus x. So if these were fractions, what would we do? Does anyone have an idea? Why don't we try this for fun? See where we go, see where it goes. If we said x over 5 plus x over 1, because x is also equal to x over 1, then could we do what we did in the last one and multiply this denominator by 5 and this numerator by 5 and just treat them like regular fractions, like we don't know any better? Then we would get x over 5 plus x over 5 plus 5x over 5. And then when we add fractions, we just add the numerators together, right? So we have x plus 5x. So we could get 6x over 5. And that's equal to 3/10. Now, normally I tell you we have to, whatever we do on one side, we do to the other. But why didn't we do that in this case? Does anyone know? So the reason is what we did here by multiplying the numerator and denominator by the same number, we are multiplying this x over 1 by the number 1, the equivalent of the number 1. So we didn't change the value, we just changed how it looked so we could add that to x over 5. Okay, so we haven't changed the value yet. All right, so this x over 5 is equal to 3 over 10. So now we have to move on to the next step. So what should we do? So well, since we're dividing on the left by 5, let's start by multiplying by both sides by 5. Okay, so 5 times a fraction, we're going to multiply 5 times the top number normally. But what we can do is this 5 will be divided by the 5 here, leaving just 6x. And 6x will be equal to 5 times 3/10, which would be 15/10. And now we can do the same kind of thing in reverse. Multiply both sides by 10 to get rid of the denominator on the right side. So these two go away. It would turn into 150 over 10, but then it reduces to 15 over 1, which is 15. So 15. And then 10 times 6x is 60x. And now from here we can just use a new color. And we'll divide both sides by 60. And that leaves this, this 60s go away and the x remains. And if you guys have been working on your multiplication tables, you should know, you should see the factors here. 15 is a common factor, and if we divide, we can reduce this fraction by dividing by the equivalent of 1. 15 divided by 15 is 1. 60 divided by 15 is 4, and so our answer should be x is 1/4. So should we give it a try and see if that works out? We'll substitute 1/4 in there, 1/4 over 5. And this is kind of a compound fraction now. Plus 1/4 is equal to 3/10. So in order to this is a nested fraction. You can go to Khan Academy and look up nested fraction to see how you can expand this. But basically you're saying 1/4 divided by 5, right, in this expression. And so in division, in math, when you divide fractions, we always say invert and multiply. Invert and multiply. So you just have to remember that rule. And we can write 5 as 5 over 1 before we invert, and then rewrite this as 1/4 times 1 over 5, which means 1 times 1, that's equal to 1, and 4 times 5 is 20. So this expression simplifies to 1/20th, okay? So we have 1/20th plus 1/4, and we want to see if that'll really equal 3/10. So in order to add these two together, we need to have the same denominator in both of them. So if we multiply 4 by 5, we have to multiply the numerator by the same number. Then we'll get 1/20th plus 1 times 5 is 5 over 20. And then we add them together, adding the numerators. 1 plus 5, and the unit is 20. So sometimes they write it like 1 plus 5 over 20. And then they add the 1 and the 5, and they get 6 over 20. And then they reduce, getting 3 over 10. And to reduce, of course, you just divide by the same number, 2 over 2, which is the equivalent of 1. So 3/10 is equivalent to 6/20ths, and that is indeed equal to 3/10. So that's the answer, and this is how you can figure it out. If you need help, come see me or check at the Math Learning Center. And this has been 6 minutes. I think I'll try the next one on this one. We'll do a twofer. All right. Oh, I didn't put the answer on there. Let's see. X was equal to 1/4, right? 1 over 4. Is that right? 1 over 4. X is equal to 1 over 4. Yeah. Okay. Awesome. All right. Here we go. No, not that one. This one. All right. This one is number 9. So 9 times negative 6x minus 9 is equal to negative 1x. And they don't usually write 1x. So they're just being kind by reminding you that way. You could say negative x minus 3. In fact, that is the more standard mathematical way to write it. So does that look like a 1? All right. So does everyone know how to start this? We're going to expand, right? So you can't really subtract. Well, we got parentheses, so we're thinking PEMDAS, but you can't really combine these because they aren't like terms, so you cannot subtract them. But we know about the distributive property, and we're going to start there. And we're going to do 9 times negative 6x. So 9 times 6 is 54. We got negative 54x minus 9 times negative 9, which is 9 times negative 9 is 81, negative 81. All right, so we have 9 times this negative 9. We've got lots of negativity. That's going to be equal to negative x. I'm just going to write x minus 3. So we have to figure out what x is. And what we're going to do is put all the x's on one side. And so let's add an x to this x and get rid of it. And add an x to this side. So we got the x's canceling out on this side. Here we have negative 54x plus a positive x. That's going to leave negative 53x. And remember the signs, when the signs are different, right? You've got a negative and a positive. We're going to take the difference between the two. So the difference between 54x and x, or 1x and 54x, is 53x. And 54 is bigger than 1. And so the negative sign is what we use. So we got negative 53x minus 81 is equal to negative 3. And I think you guys know what to do next, right? Let's go to purple. We're going to add 81 to both sides. That cancels this out, plus 81 over here. Again, the signs are different, so we'll take the difference between the two. So we'll have 78, and the larger number is a positive. So it's positive 78, or you can just write 78. So negative 53x is equal to positive 78. And how do we get rid of that negative 53? You got it. We're going to divide it away because it's multiplying x by negative 53, so we're going to divide it by the same negative 53. Don't forget your negative signs there. and we're going to divide the 78 by negative 53. So the negative 53's divide out to produce 1x, which is x, and x is going to be equal to 78 over 53. And in math, we usually like to have the negative sign in the numerator. We like to have a nice clean denominator, and that usually means not negative. So can this be reduced at all? Is 53 divisible by some number? I don't think it is. I think 53 is a prime number. So I think this is our final answer. And if we plug this back in up there, let's try it. We'll do it down below. 9 times negative 6 times negative 78 53rds minus 9 is equal to negative, now this is negative 78 53rds. So that's going to go positive, right? Minus 3. And let's just try this. We can do proper PEMDAS now, working within the parentheses. So we have two operations, multiplication not written and subtraction, which is written. So we're going to start with negative 6 times negative 78. So let's just do 6 times 78. The signs are matching, so the answer will be positive. 6 times 8 is 48, carry the 4. 6 times 7 is 42, plus 4 more is 46. So 468 positive, right? We've got 468 over 53 minus 9. Keep those parentheses. And we're going to multiply that by 9 when we get there, and that should be equal to whatever is on the other side, if we got the right number. So 468 minus 9, we can write this as minus 9 over 1, right? Just turn that into a fraction. And then we need to have the same denominator. So we're going to multiply the top and the bottom by 53. And 53 is a prime number, so we can't factor it down. And this is going to be 468 over 53 minus, and then 9 times 53. So let's do it the quick way. 9 times 50 is 450. 9 times 3 is 27. Let's add those together. We'll get 774. Put this up here, 477 over 53. And now we can subtract those, right? So this is a positive 468. This is basically a negative 477. So we're going to take the difference between the two numbers, which is about 9, right? 9. And the larger number is negative, right? 477 is bigger than 468, so the answer is going to be negative. Negative 9 over 53. And then we have to multiply that by 9. Let me just get rid of the equal sign. All right. We have to multiply that by 9. So let's do a different color. 9 times, oops, hey, I was still in erase mode. Bring it back. 9 times negative 9 over 53. We just do a positive 9 times a negative 9. That's negative 81 over 53. So when we figure this out, we should get the same answer. And this is looking pretty promising because we have the same denominator. So, and here we have negative. This is, we have to distribute the negative over this, right? So we'll do that. Negative makes it positive. So we have positive 78 over 53 minus 3. Okay. So to do that, we're going to change 3 into a fraction. Just put it over 1. And let's write in I guess we can keep our parentheses here. So for this to work, we need a 53 here and a 53 on top, right? So 3 times 53, we'll do this the same way. 3 times 50 is 150, and 3 times 3 is 9. We'll get 159. So we've got 78 over 53 minus, and this is negative, so minus 150. So over, oops, 159. There we go, 159 over 53. So we're subtracting that, right? So we've got a positive and a negative. We're going to take the difference between the two, which is the same as subtracting one from the other. 9 minus 8 is 1, and 15 minus 7 is 8. We're going to get 81. And the bigger number is negative, so that's a negative 81 over 53. So that's a good answer. All right. And I'll put that in up here. X was negative 78 over 53. Okay. Awesome. All right, that's all for this one. I'm going to try these next two in the next video. See you there.